This is a little bit different from what we've seen before. In particular, there's one little twist that we have to really pay attention to. So let's take a look at the first one. Oh, and there's a lot of different types. So you have to get familiar with the different types. Kind of depends on, it depends on a few things, but part of it depends on where is the x. So you see example A there, like x is in the logarithm, x plus 1. And B, x is in the base. And we've seen somewhere x is like the result of doing it, how to do that. We've seen those before too. So you got to know how to do each. And I would imagine, and the little twist that we're going to get to, kind of an example B and C, but more so later on. I think some people get confused about when that is applied. Okay, it has to do with negatives. So when is this relevant? When is this not? And so we'll try to talk about that, but that's something that you should spend some time thinking about. Okay, so the first one, if I think about what a logarithm is, this is, writing this in exponential form is actually by far the easiest way to solve this. So this means 3 squared equals x plus 1. Right? The base stays the same. The result of a log is the exponent in exponential form. So base 3 to the 2. If you know the base, that's not x, and you know the exponent, that's not x, that's probably kind of the safest way, especially in a case like this, is how we would solve this. So it becomes easy, but again, when you start to mix it up with the other types, it can get a little bit trickier. So this is 9 minus 1 equals x, and x equals 8. Easy, straightforward. The next one is similar, but I think this is the first time we've seen x in the base where we're trying to solve. We've seen examples where the base is a variable like we just took up on the learning goal, but that was different. So again, this one I'm going to write, because I have the exponent. And what do you do here? Take the square root of both sides, and we get x equals, be very careful from grade 10. Right, plus minus 4. So then I'm going to go like this. X equals 4. X equals minus 4. And let's think about this. How could I check this work? Everybody got their calculator out? Turn it on. Remember your change of base formula? If I want to check it, I would do log 16 divided by log of 4. Do that. What do you get? You got 2? Yes. Work. Okay, just try the next one. Log 16 divided by log of negative 4. What? Error. Calculator's broken. Throw it in the garbage. Somebody else, what did you get? Error. Oh my gosh. So, kind of by definition, at least for grade 12, logs don't have negative bases. There is math where you can do it, but it's more advanced than what we have. So for us, we can't have logs that are negative bases. Similarly, this is going to come up a little bit later. What if 16 was negative? Well, if I can square a number, I can't get a negative, but I cube a number, I could get a negative. If I go to the 4th of a number, I can't get a negative. To the 5th of the number, I can get a negative. This is that inconsistency of these things that we talked about. So in some cases it will work, but in some cases it won't. And so like with the math that we know, we would say logs are undefined for those kinds of numbers. Because even though it will work in some cases with a negative inside the log, in some cases it doesn't. So you'll notice your calculator just always gives you an error. Here's something else that's interesting to me. This is just an aside. Don't write this down. What if I did log of, what would be good here? Log base 3 of negative 27 minus log base 3 of negative 9. I'm going to change that to negative 3, but it doesn't make a difference. Like, if you tried those on your calculator, you're going to get errors. It's not going to work. But if I did this, log base 3 of negative 27 over negative 3, that gives me log base 3 of 9, which does work. But your calculator still won't, it won't work for that. Or, I mean, maybe there are calculators out there that will do it, that do it differently, but mine certainly gives an error when you try to put it in like this, or if you ever take log of a negative, it won't work. So, even though in some cases we can kind of find a value, typically when this stuff happens, it means that it's an error, so it's like undefined, so it doesn't work. And in this case, we can't have a negative base in our log, so inadmissible. Does that make sense? Everybody okay? Okay, couple of ways to do this one. And you don't need to know both. I think the normal way of doing this would be to go, so what's the base? It just says log of x squared. What's the base? It's 10, right? So 10 to the 4 equals x squared. If I take the square root of both sides, what do I get? Yeah, nice. 10 to the 2 and like plus minus 10 squared equals x. So x is plus minus 100. And we just finished saying, well, what about having a negative in... Like, what if the 16 was negative? You can't do that either. So the negative, and don't worry about this too much. I don't think this is really ever going to come up. This is not something you need to worry about. But actually, in this case, the negative would be okay, because when you put it in for x and squared, it's going to go away. So the negative 100 in this case, because it's x squared, will actually work. But anyway. So that being said, if you did on a test, if you put either answer, plus minus 100 because you did it this way, or if you just ended up with plus 100, I think that would be okay. That would be fine for me. Because the other way that you could do it, I don't know if you want to write this down, but you can just watch, is I could take the 2 out front, 2 log base x equals 4, divide both sides by 2, log base x equals 2. Yeah, thank you. Okay, and then 10 squared equals x. So x would be just 100. Where did the negative 1 go? So a little bit tricky. So again, like negative or just positive 100 would be fine for this. Sort of technically, negative 100 would work as well. And there's like some mathematics softwares out there that'll give you both answers, but either way it goes fine. Does that make sense? Everybody okay with that? Or is that too much talk about negatives and that's confusing? Like question B is something that we need to think about and understand. Question C, it doesn't really come up in the practice or anything like that. It's not really as big a deal. Okay. D. So again, what do I notice? I notice that the logs are in the same base. They're both log base 10. So if I rearrange this a little bit, just like we do with exponents, where if you equate the bases,
if you have the same base, you can equate the exponents, right? So if it's 3 to the something equals 3 to the somethings have to be the same. The same is true for logs. It's not something we've talked about, but you would probably guess that, right? So and as long as I don't have anything else, like plus 4, if I've got other junk going on, then this isn't going to work. But if I have same base logs, log of something equals log of something, those somethings have to be equal. So we say, therefore, x equals 16 to the 1/2. And what is 16 to the 1/2? This is square root of 16, 4. Plus or minus 4, except again, we can't take the log of a negative number. So we would have to split that up for x equals negative 4. Inadmissible. Everybody okay? Same thing. Why don't you try this one on your own? So we notice that it's log base 2 of something equals log base 2 of something. Therefore, do we get negative 3? And so I think it's, for a question like this, it's not going to be an issue, but it's a good idea to start thinking about restrictions. Does my answer make sense? Is it a real answer? Very similar to when we did rational expressions. We did solving rational equations, and we would sometimes state restrictions ahead of time, but like if it's not in the solution set, then it doesn't matter. Okay, it's sort of similar here. We have restrictions. Sometimes they might be important and sometimes they might not. Everybody okay with that? So these are sort of, I would say these are like the simple ones. Notice they only take a couple of steps. Sometimes we got to think a little bit about our answers, but for the most part, pretty straightforward. Just where's the x and exactly how do you rewrite and set things up. Okay, and these ones are a slightly different flavor of question. Anybody have a guess about how we might start a question like this? What's different about it? Well, in the last examples, we only had one log, or we had one on each side of the equation and nothing else. So this one's different. So I don't know. What would you do, Doriana? That's a good idea, but not at this stage. Not yet, at least. Vivian? We could use a product law. Now, whether or not that's going to be helpful, I guess is a guess, but it turns out, yes, it is. So this is like log of x plus 1 times x minus 3, right? Log base 5 of all that. If I'm adding them, I can multiply. It's in the logs. Equals 1. And rewriting this with log notation would mean, therefore, I don't have to say therefore in this case because I'm just rewriting it, but equals 5 to the 1, right? The base stays the same. The result is my exponent. Everybody okay with that? If you're not, go back up here and sort of think about what we did, like in example A, for example. Okay? It's the same idea. Okay, so now we just solve. X squared minus 2x minus 3, and then I'll take the 5 to the 1, which is just 5 over, minus 5. I got 4 and negative 2. Does that look okay? However, if I go back up to the original question, if I put 4 in there, you could do a left side, right side check just on your calculator. Log base 5 of 4 plus 1. Log base 5 of 4 minus 3. And it will give you 1. In fact, that works out nicely. You could do it in your head, or you could do it easily on paper, because the numbers all just work out. They don't always, but in this case they do. Okay, so it works out. That's fine. What if I put negative 2 in? Log base 5 of negative 1 plus log base 5 of negative 5. That will not work. Try it on your calculator. You get errors, right? That's what we just talked about. So what this means is, we didn't do this ahead of time, but I actually had these restrictions where this bracket, in fact, if that bracket is 0, it'll give you an error. Like, think about what that means if that bracket was 0. Rewrite it in exponential notation. Okay, and so so what we say is x has to be greater than negative 1, and x has to be greater than 3. But if x is greater than 3, it is greater than negative 1. So really our restriction is x has to be greater than 3. To me, there's no formality here, but it does mean this one's inadmissible. So in terms of stating the restrictions, you can do it for your own benefit. Or when you get to the end, you can think about your answers and make sure like which one makes sense, like you would have done in grade 10 when you're solving quadratics. Sometimes they might both be okay. With logs, that doesn't tend to work out that way. Usually you're tossing one of them aside. But sometimes both are fine. Sometimes neither might be fine for whatever weird reason. And sometimes, one of them's okay and the other's not, or something like that. All right, I want you to try the next one. It's going to be answered the same way. Some of the math will work out a bit different, but same idea. Get that as a first step. So again, product rule, multiplying. So it looks like we got x is 8 and x is -2. But if we look, -2 won't work. So the answer is x equals 8. Any questions? So this is a bit new, right? This is a little bit different. The other stuff, fairly similar to what we've already done. Not too much of a stretch, but this is a little bit new. How you actually do it, like the algebra involved, right? Multiplying these together using the product law. And then also thinking about restrictions and what answers actually make sense. Okay, one more. I don't think you want to write this down. Especially don't write down the top part. It's in the textbook. If you've ever wondered about how they find the magnitude of an earthquake, you've heard of this before. I'm sure it's called the Richter scale. Has anybody ever, have you ever studied this in another class? Talk about it in science or anything like that? Grade 11 geography? Yeah, interesting. Okay, so there's the equation. R equals log of A over T plus B, where A is the amplitude of the vertical ground motion. We know what amplitude means. It actually means the ground moving, which is weird, which is what an earthquake is, but it's weird to think the ground is actually moving and has an amplitude, right? So you can measure that amplitude somehow, I guess. T is the period of the seismic waves. Again, we understand what that is. And B is this number that helps make it all work and make sense. It's a little strange, but anyway, that's what it is. And R is obviously like that Richter scale number that you've heard of. So if an earthquake measures a 7.1 on the scale, T is 1.5, B is 4.2, determine the amplitude of the ground. So find A. In other words, there's a couple of applications in the practice tonight, and really they're just like, here's an equation, plug the numbers in and solve like you've been doing it. There's not much to it. There's not like a lot of setup involved or anything like that. But we will do some more applications later on, probably in January. So here we go. R equals log of A over T plus B And I hope this feels familiar, the kinds of stuff similar to, I don't know if we've done anything quite like this, but it's very similar to exponential stuff. So we got to start like isolating and kind of moving things around. So subtract 4.2 from both sides, and you get 7.1 minus 4.2 is 2.9. And it's kind of cool here. You got two options. Log of A over log of 1.5. I could use the quotient law and split those up if I wanted to. Log of A minus log of 1.5. In some cases, that might be a nice way to do it. Or I could rewrite this in exponential notation. This would be like 10 to the 2.9 equals A over 1.5. Multiply both sides by 1.5, and A is 1.5 times 10 to the 2.9. Right? So kind of either way, I guess, better work out the same. One 191.5. And I think A, that's like, so the ground, the amplitude of the ground was 1,000 feet. No, it's not. It's in like very small units. So I think that number makes sense, but I don't actually know. I just kind of made up the numbers. So
But I think that number is reasonable.
7.1 is big. So that would be on the bigger side of the kind of amplitude you might find. But anyway, any questions?